Question 6 says Andy, Luke, and Tina share some sweets in the ratio of 1:6:14. Tina gives 3/7 of her sweets to Andy. Tina then gives 12.5% of the rest of her sweets to Luke. Tina says now all three of us have the same number of sweets. Is Tina correct? You must show how you got your. I must show how you get your answer. So to show if Tina is correct, what we're going to do is first we're going to create fractions from this ratio for all three. We know Andy is 1/21. We know Luke is 6/21. And Tina is 14/21. Now, Tina is giving 3/7 of her sweets to Andy. So, if she's giving 3/7 of her sweets to Andy, we multiply 14/21 times 3/7, which gives us 6/21, which simplifies to 2/7. Now, remaining sweets for Tina is going to be 14/21 minus 2/7, which is equal to 8/21. This is what Andy got from Tina. Okay. So now from these remaining 12.5% were given to Luke. So before we do that, I'm going to write what Andy has now. Andy has 1/21 plus 2/7 now, which is 7/21. This is what Andy has. So I'm going to highlight this over here. This is what Andy has right now. Now going back to Luke. So for Luke, we're going to first find 12.5% of 8/21. So 8/21 times 12.5/100, which equals to 7/1/21. So now Luke will have 6/21 plus 1/21, which is 7/21. So let's highlight this as well now. This is what Luke has. This is what Andy has. Now to find what Tina is left with, again, remaining, or more like Tina final sweets. Tina final sweets. For Tina, our final sweets are going to be 8/21 minus what she gave to Luke, which is 1/21. That is 7/21. As you can see, all three have the exact same fraction for sweets. Tina 7/21, Andy 7/21, and Luke also 7/21. Let me just highlight this over here. This is what Luke got from Tina. So if we compare them, it's exactly the same. They'll have the same ratio. 7/21 is to 7/21 is to 7/21, which simplifies to 1:1:1. So yes, she is correct. Question 17 says L, M, and P are similar solid cylinders made from the same material. L has a mass of 64 grams, M has a mass of 125 grams. M has total surface area of 144 centimeters square. P has total surface area of 16 centimeters square. Work out the height of cylinder L is to height of cylinder M is to height of cylinder P. So what we will do in this case is that you need to remember that when an object is made from the same material, that means density is same. Now density has the formula of mass over volume. So if we pick solid L first, density is 64 divided by volume of L. For M, density is 125 divided by volume of M. Like I said, same material, same density. So we can put these fractions equal to each other. 64 over VL equals to 125 over VM. Swap the places, 64 over 125 equals to VL over VM. Now, if you remember, in similar shapes or like solids, whether it's like 2D or 3D, your ratio of the volume is equal to the ratio of the cube of the length given for the shape. So basically what I mean is that this equals to this. So that means this is 64 over 125 can be put equal to this, and we can find the height of shape L and M. So 64 over 125 equals to HL over HM cubed. Take the cube root, and that gives us 4 over 5 for HL and HM. So we have a ratio for HL and HM. Now we need to figure out the ratio for P. So for M and P, they have given us the surface area. So what we're going to do is that using this same concept for your similar shapes, we know that area of M over area of P is the same as HM over HP being squared now. In case of volume, we cube it. In case of area, we square the ratio. So area M 144 over 16 equals to HM over HP squared, square root both sides, and we have 1204 for HM is to HP. Now we can see that we have common HM in both the ratios. So what we will do is that we're going to write them separately and then combine them. So HM is to H. So HL is to HM is 4 is to 5. HM is to HP is 12 is to 4. As you must remember, when you're trying to combine two ratios into one single ratio, you need to make sure that the common quantity in both the ratios is the same. In our case, that's the height of M. Now, M is 5 in the first ratio and 12 in the second ratio. So to make it the same, we need to multiply this by 12 and this by 5. Now, since this is being multiplied by 12, we have to multiply this by 12 as well and this by 5 as well. Because you can't just change one quantity, you have to change both of them. So that's going to be 48 is to 60 is to 20. We can combine it as a single ratio now because we have the same quantity for HM now. Now, if you simplify this, they're all divisible by 4. This is going to be 12. This is going to be 15. And this is going to be 5. This is your answer. Question 18 says there are only 4 red counters, 3 yellow counters, and 1 green counter in a bag. Tony takes at random 3 counters from the bag. Work out the probability that there are now more yellow counters than red counters in the bag. You must show all your working. So right now we have 4 red counters, yellow 3, and green 1. We have to work out the probability that there are now more yellow counters than red counters in the bag. So that means he's taking red counters out. So Tony will be taking more red counters out of the bag. So let's in the first try, he's taking all 3 red counters out of the bag. So when he takes all 3 red counters out of the bag, which is 3 red counters, So red counters are 1, yellow counters are 3, and green are 1. So as you can see, there are more yellow counters left in the bag if we take 3 red counters. So that's 4 over 8 times 3 over 7 times 2 over 6. This is the probability for all red counters. Now, the reason why it's 4 over 8 times 3 over 7 times 2 over 6 is because he's not replacing the counters. He took 3 counters, so there are 3 less counters in the bag. So when he took the first red counter, the total number of counters reduced to 7 and the number of red counters reduced to 3. Then when he took another red counter, again, like 1 reduction. So that's why it's 4 over 8 for the first red counter, 3 over 7 for the second red counter, and 2 over 6 for the third red counter. That gives us the probability of 1 over 14. Now, the second condition is that he takes 2 red counters and 1 green counter. The reason why I did not take 1 yellow counter is because if we took 1 yellow counter and 2 red counters, that would leave us with 2 red and 2 yellow. We don't want that. We want the yellow number to be greater. Hence, we took 2 red and 1 green. So that's going to be 4 over 8 times 3 over 7 times 1 over 6. So that is going to give us 1 over 28. Now, since the combinations for us taking red and green can vary, we can take red, green, red, or we can take green, red, and red. So while keeping that in mind, we have to multiply this probability by 3. 1 over 28 times by 3, that's going to be 3 over 28. Now, we don't have a third condition because if we took 1 red, 1 green, and 1 yellow, the number of yellow and red counters would be the same. So either we can take all red counters, like all 3 red counters, or we take 2 red and 1 green. We cannot take a yellow counter in any case because yellow counters are already less than the red counters. So they're asking us to work out the probability that there are now more yellow counters than red counters. So for that, we added 1 over 14 and 1 over 28. And that gives us 3 over 28. That is your answer. Question 19 says diagram shows a quadrilateral OACB. M is the midpoint of OA, N is the midpoint on BC such that BN is to NC is 4:5. OA is given as A, OB is given as B, and OC is given as K times B, where K is a positive integer. We have to express MN in terms of K, A, and B, giving your answer in its simplest form. So MN is this. And what we can do is that to find MN, we know M is the midpoint of OA. So that means this is A over 2. OB is given as B. And AC is given as K times B. So first, I'm going to find BC. So BC is going to be BO plus OA plus AC. That's negative B because OB is given as B, so BO would be the opposite, so negative sign. Plus A because OA is A and AC is K times B. So this is our BC. So we know N is on BC with the ratio BN is to NC is 4:5. So to find BN is going to be 4 over 9 of BC. This is what we're trying to find. So that's going to be 4 over 9 times negative B plus A plus K times B. So to find MN, I'm going to do MO plus OB plus Bn. These are the vectors I'm going to use to find Mn. So that's going to be Mn is Mo plus Ob plus Bn. So that's negative A over 2 plus B plus 4 over 9 times negative B plus A plus KB. So when you solve that, we have a denominator of 18 and we have negative 9A plus 18B minus 8B plus 8A plus 8KB. So if you simplify that, that's going to be negative A plus 10B plus KB over 18. This is what I get for Mn. Then is Mn parallel to OB? So Mn was negative A plus 10B plus 8KB over 18. OB is B. Mn and OB cannot be parallel to each other because Mn has the vector A in it, whereas B doesn't. So no, they're not. Because Mn has vector A. Question 22 says A and B are points on a circle center O. MAP and NBP are tangents to the circle. Prove that AP equals to BP. So this has to equal to this. So first, we need to remember that OA and OB are equal because they represent the radius. So OA equals to OB because radius. Second thing is that the line OP is common between both these triangles. So OP is common. So this is another equal length. So we have two equal lengths so far. And the third thing is that a tangent makes a 90-degree angle with the radius. So angle PAO equals to angle PBO, which is 90 degrees. So we can clearly see that both the triangles are congruent because they have the same angle, they have the same two lengths, so third length is also going to be the same. And the property we're using is that side angle side. And by CPCT, your AP is equal to BP. That's how you prove that AP is equal to BP, because they're both right angle triangles and their radius that's congruent, the common length that's congruent, the angle is congruent. So yeah.